Yeah, it didn't work so good though with those guys.
Yeah, I was wondering.
Can we use yours instead or mine?
I was wondering, are we expected to use that?
I don't think so. It said you can use it at your convenience.
Yeah, I'll use my laptop then, since I got all the slides too. Hoping I can use my laptop.
Most of the team that's here today, and that's all we have any team that
Works. Oh yeah.
You're still very tiny.
I think all I have to do is press this button up, please. One speaker.
Unmute them.
You have to press this just once and that means on.
And unmute it, and then when you want to mute again.
I can just press it again. Oh. Okay. Yeah.
Good for you, I haven't seen you all.
Yeah. Me too. Yeah, so welcome to PIM working group. We need a minute taker. See, Greg stepped out of the room. Anyone willing to take minutes?
Okay.
There's more people coming. Yeah, we got a pretty full agenda and we can't start until we get the minute taker.
Monkey mine. I'll take notes. So we'll between the two of us. Very good. Thank you.
Okay, great, thanks. All right, so this is a note well that you all should be aware of. This is for all IETF work, not just the PIM working group. And this is the agenda. Any comments on the agenda? So, kind of try to order this so that the same speaker more or less can take you all the documents at the same time. The order is fairly random. All right. Yeah, I did try to do the working group documents first, though, roughly speaking. Anyway, okay. So this is our status. This last time we published RFC 8364, which is PIM flooding mechanism. The PIM Yang model is now in the RFC editor's queue, so it's been approved. It's just waiting for the editor to do the final editing. So in a few weeks now, we should have our first Yang model, which is great. And we got several more models coming. Multiple upstreams requirements. We agreed to publish that. The area director had several comments on that, so we're waiting for a new revision.
Hi, this is Carlos Bernardos, co-author of that draft. I've been discussing with the co-authors, especially with Luis from Telefónica, and basically we will provide, our aim is to submit a version this week, so maybe we can also take some break to discuss with Alvaro the changes that we provided. So that's our goal.
Yeah, if there's anything you feel like you need to hear what the working group thinks or check the working group, please also send some mail to the mailing list. We also have an IGMP MLD Yang model that is waiting for the AD to look at, but hopefully ISG will be happy with it and it will move forward shortly. And then we have explicit tracking, which has been stuck for a while. I know the author is getting some other people involved, and looks like it will move forward. Yeah, Hitoshi.
Yes, Hitoshi said. It's a little bit complex. So the requirement from AD, as you know, is that we need to definitely include some statement about implementation or experiences given by operators. And because this is the intended status is experimental treatment, so lack of such kind of information, so ADs cannot approve as explicit RFC. So now we have been thinking about changing of the intended status to informational, but this is also, there are several concerns given by, let's say, Torres, but Torres is not here. Because in the last MBOB meeting, express tracking is, even though there is no wire changes, it's really important as a part of IGMP v3 or MLD v2. So that this kind of functionality must not be maybe informational. So this is something like his opinion, and this was something like a consensus of the his previous meetings. So this is something like a reason that why it's a little bit stacked. And so the possibility to make it move forward is that, as you said, we definitely need to get some input from vendors or operators to become a good guideline of this functionality. So please read the document, and if you're a vendor or operator who has the implementation experiences or operational experience, we are really happy to get such kind of information, and we can summarize these information and describes the summary into this document, and continuously work on as experimental documentation.
So the draft will be on hold until you do get that implementation information?
Yeah.
Even if it's experimental draft?
Yes.
Okay. So we need to, as a working group, help you to get some of that implementation information.
Yes, please.
That's out there. Okay.
Yes, please. Thank you.
All right. We also have a DR load balancing draft. So it's a long story about that, but yeah, we'll have a presentation about that in this meeting. We also have DR improvement. There's no update this meeting. We need people to review the draft and comment on it. There's also some related draft that will be presented in this meeting. We'll come back to that later. For MSDP Yang, we had a working group last call and no one responded. I did a review after that. I should have done it for the last call myself, but I did it after. And the authors have revised the document, and it's probably a good idea to do a new working group last call. I'm hoping, since people thought it was ready for last call the last time, people are still thinking it's ready for last call now. So unless anyone has any concerns, we plan to do a working group last call again, and then we just really hope that some of you will respond so that we can move this draft forward to an RFC. Okay, we also have a Yang model for IGMP MLD snooping. We have a presentation for that this meeting as well. That should be close to completion. And there's a draft on IPv4 prefix over IPv6 next hop that also will be presented this meeting. So that's the status of all the current working group documents. Any questions before we move on to the presentations? All right. Okay, so let's see. So first presenter is Yusong.
Good afternoon, everyone. I'm Yisung from Huawei. I'll introduce the IGMP and MMD snooping Yang model and the IGMP and MMD Yang model updating information. Firstly, for the IGMP and MMD snooping Yang model, from last IETF, we have updated according to the draft IETF net mode RFC 6187 bits and other review comments, and we will also update after the this IETF for the comes from the young doctor. The first mainly we update is the robustness variable parameters range change from the 2 to 7 to the 1 to 7, because in the RFC that the value can be 1, and so we discussed and decided to add the range of that. Okay. The second mainly update is that we add an example of the data tree followed by the JSON encoding. For example, this is the IGMP snooping instance. So we are we discussed in the Young design team. We are ready for the working group last call. Okay. Any comments for this draft?
So maybe I'm mixing up with a different draft, but this was the last one we got the Young Doctor review on, right? I think.
The Young Doctor review has and
yeah.
Oh, okay. Yeah, the Young Doctor have reviewed, but we wanted to in the Young design meeting, and we discussed and respond to the Young Doctor, and then we think we can start to the last call.
So you think it will be just small changes needed to
we think we don't need to change.
Oh, okay. Okay. No, because based on the review, it looked to me like maybe there were some bigger changes. But yeah, if you don't need to do that, then that's fine. Yeah. So I guess we should ask the room maybe. So yeah, how many people have read this draft? Let's see, about 6 people. 6 people, I mean. So, how many of you think that this is ready for last call? Let's see. Okay, it's roughly the same people. Anyone have any issues or think that something must be addressed before it can go to last call? Okay, I think we'll do a last call on the list then. Right, Mike?
Yeah, we need to do that. With these Yang model drafts, it's always like pulling teeth to get response on the list. But at least a few people that have just raised their hands can respond on the list. That would be enough for us to progress this draft. And that's true for the other Yang draft as well.
Yeah, so I think we should do a last call for MSDP right after this meeting. And then when you have, publish your next revision,
Okay.
assuming it's only small changes, we'll do a last call on that one.
Okay. And the second, we introduced the ITMP and MLD Yang model. From the last IETF, we have made some updating from the comments and the AD and the chair's comments. Firstly, we update according to the IETF MET model RFC 6 or 87 bits, mainly the part of the security considerations and the reference information. And the same as the ITMP snooping Yang model, we also updated the range of the robust from 2 to 7 to 1 to 7. We think that we can ready to start another call.
So this one was not snooping, right? Just basic IGMP MLD. But that's already approved for publication, right?
I do not understand the period of the
Right.
process.
Right. So, if I remember correctly, for this draft, we requested publication, but then the young doctor had some comments, and I think we were waiting for you to review that before our AD would, review the document further. So I'll go and check, but yeah, I believe that the next step now will be that Alvaro probably will review the draft and determine, if it's ready for ISG.
Okay.
But for the snooping one, we need to do a working group last call.
Okay.
Do you review Yang drafts, Alvaro? Is that something you do?
Yes. So, so usually the process is if it hasn't been through the doctors, then I send it through the doctors. But if it's already been there, then I take a look and whatever issues are there, just like any other draft. So yes.
Okay. That's
Okay. So yeah, all is good. We'll move forward with the drafts.
Thank you.
Yeah.
Good afternoon. So this is small update for the draft DRL load balancing. So basically, I think it got adopted as a working group in IETF 82, and there was a big pause in between, and finally IETF 99, I did present it in Singapore, and IETF 100, we had some comment from Jack Holland, and I did update the document, and just 2 hours back, I think he has sent me some more comment, but after addressing his comment, I think it is ready for working group last call, until unless there is any other comment. No? Then we are good.
Is this the last slide?
Yeah.
Okay, yeah, let's do it. You're on this. Yeah, I better go because you're on this one, right? Yeah, yeah. All right, so we discussed this briefly on the list. We said we would discuss it here in this room. So who believes that this draft is ready for working group last call? Do any of you believe that it's not ready for working group last call? Who has read this draft? Okay, so we've got a couple. So those of you that read the draft, I'm assuming then you don't think it's quite ready for working group last call. Is that true? So I'm just gonna ask one last time because we're kind of done with this draft, but I don't want to force it. So does anybody in this room feel that this draft is ready for working group last call? So I don't see any hands. Do you believe it is? Okay, I got a hand. All right, we got a hand. All right, so we will need to take this to the list.
Sure.
If we can get a couple responses, then we'll move it along because there's no hands against.
Okay.
It's just there's not a whole lot of interest apparently.
Sure. So, next topic to discuss. So I think we already have, there is a draft which is PIM DR improvement, and it talks about backup DR mechanism. And so I'm just trying to capture once again here that what is the problem the other draft is solving. So if you see here, we have a receiver at the end, and there are two paths to source. I have kept it very simple. And the left side, the R8 and R9, they are PIM routers on the LAN, and R8 is PIM DR right now. And all the PIM joins are going from R8, R6, R3 towards source, and we have data traffic flowing. And what will happen if there is a failure here? So if there is a failure, basically receiver is going to get the traffic loss here. And it's not only about the traffic loss, what will be the next step? So basically now R9 becomes the new PIM DR, and R9 has to build the whole tree again to receive the traffic from source. So it sends PIM join hop by hop, then we start getting the traffic, and that's how receiver starts getting the traffic. But in this case, so there are certain applications, for example, surveillance camera, if they are using multicast, and if there is a big pause of 3 seconds or whatever time, so there are security concerns, and there could be some important traffic which you don't want to lose. In that case, there are vendors who are ready to have duplicate traffic in the core just to make sure that our, in case of failure, the convergence time is really low. And so basically in this draft, I am trying to see that if we could have an alternate way other than what PIM DR improvements talks about to solve the same problem. So in this we are saying, so even the PIM DR improvement drafts talk about having backup DR. So in case of backup DR, what exactly we are doing? R8 here is a DR and R9 is backup DR. Both of them, they will build the multicast tree towards source. Both of them will pull the traffic, but R9 will keep dropping it because it is in the backup mode. And R8 will keep forwarding the traffic. What will happen now if R8 goes, the link between R8 and receiver goes down? In that case, R9 already has all the traffic. It's only a matter of the time when it can detect. And if you're using BFD or any other mechanism to detect it fast, R9 can immediately detect and it can start forwarding the traffic. So it doesn't need to wait for the new tree to get set up.
So just to clarify, so what you presented so far, that is true for both the drafts?
Yes.
Right? Yeah.
So now what is the difference here? So basically, the major difference which I am proposing here, the draft PIM DR improvement talks about having new hello option to have backup DR election. But I think that we don't need new new hello option. We can still do it with existing hello option. And I just wanted to take it to working group here to have kind of discussion and maybe have analysis that which one will be the better to go with, or both of the options are good. If both options are good, what exactly we are going to do? I mean to say,
Do we want to proceed with both of the draft or one of the draft or merging of the draft? So let me see if I. Okay, so in this, I think it will be easy with figure what exactly I'm saying, that if you see now R8 and R9 both are PIM routers. When they see each other's hello, what exactly they are going to do? They are going to run the same algorithm of PIM-DR election, and the first, whoever is the best router will become the PIM-DR. The second best router becomes PIM-BDR by default. And when you are in the BDR mode, you still send the PIM join. You do everything whatever PIM-DR does. Only thing is that you have to be in block state. You should not be forwarding the data traffic towards the last hop. And there were few cases, I think I would say more of corner cases, which need to be handled. That what will happen if new PIM-DR comes into the network. So the main concern was that if it sends its priority right away, it might happen that the other router, other router will give up its role and we will still see the traffic loss. So for that, we had that what if you don't send your actual priority right away? You send your priority as a 0 and you wait for one hello interval to learn about all of your neighbors. So after one hello interval, basically you will have full knowledge of other PIM routers in the network and their DR priority. And once you know their priority, you will be able to calculate whether you are eligible to be DR. If you are eligible to be DR, you start building the tree and still don't give your configured priority. You build the tree, and once your tree is ready, right now you will be in block state. And once you think you are ready, and so basically I have written here as a X hello interval because it's more of point to discuss that what should be the value, whether it should be 1 or it should be 2, depending on that how tolerant we want to make our network. And after this X hello interval, basically you start sending your original priority and you take over as a DR. But if new PIM router which is coming up is not it cannot be a DR. So it will know within a one hello cycle that I am not eligible to be a PIM DR anyway. So it doesn't need to do anything, and definitely it can send its own configured priority. And there were some concerns about the initial startup case when there are, let's say, 5 routers coming up together, and if everyone sends 0, so basically it will be kind of more of everyone is in waiting on everyone else. So in this case, I think it is one of the definitely corner case that when all 5 routers are coming up together, and if we have 2 hello interval traffic loss, I don't think it is a big deal, because anyway your network is coming up fresh, so we can live with 1 minute traffic loss. So in this case, when you send with 0 priority and you start getting 0 priority from others, it means that it is time for you to start sending your original priority. So is there any questions here?
Can you go back to the original picture?
Sure.
Yeah, so this strikes me as a really narrow case that you're really just solving a really small part for a very narrow case. So you still have the failure detection with or without this mechanism. You have to find out that the DR dies. So you have to, it takes time for so with or without this, you have that. All you're doing is you're eliminating join latency on one path.
Yes.
Now, and you're only doing this for one router. Meaning, what if R6 fails? Like, what if the link between R8 and R6 fails? Then what, right? Then you have to have R8 convert. You have the same exact problem. So all you're solving is join latency for one hop in a many, where any other of these hops could also fail, and this doesn't solve it. So there's a thing like there's MOFRR that kind of solves those problems. So essentially what this is just MOFRR at the LAN, receiver LAN.
Okay, so to answer your question, basically if you I think maybe it was not clear. The problem statement of this document, it is the exact same problem statement what one of the working group document is solving. So problem statement is same. Only thing is I'm trying to simplify the solution rather than having DR and backup DR using new hellos. Can we do it with existing hello? So this document doesn't solve any problem apart from what the document is already solving. So PIM DR improvement. Yeah.
And then the other thing is, do we even need to specify this with an IETF document? Because what stops an implementation from just doing this anyway? That this seems like an implementation thing that you could do. Just have a backup designated router, send joins, and sit and hold that traffic. Don't forward it on the LAN, and send it out. It seems like this could be done as an implementation thing without any kind of IETF spec.
Yeah, so it is kind of implementation, and that was the reason to bring up to working group that do we really need new hellos? Can we live with the existing hellos, PIM hellos?
Hi, Ravinder here. So I see a little bit of issues on this diagram. Like there is in a normal production environment, there is always a link between R8 and R9, like using a VRRP or something. So it's not a 3 second or a 4 seconds outage. It's like a sub-second outage. So there's no real problem to be solved on a service provider side network. We are seeing a big issue, like if you're going to start sending another traffic on another path, which can be a huge, like for a security company or a monitoring, it's a very small amount of traffic. But think about the video traffic on a video backbone where we are running a 4K videos. It can be like a tens of gigs of traffic that redundantly you don't really necessarily need for a sub-second outage. Once these scenarios goes into implementation, we would like to see it as an optional, not as rigorously put into the protocol itself.
So to answer your question, basically, even if it is in the protocol, it won't be like it is must have. It is definitely a need basis. So it's kind of trade-off. So there are a couple of customers who don't care even if you bring 3 copy of the traffic in the core, but they need faster convergence. So definitely it is nothing stops that you can still go with the existing PIM-DR model, but this is the method. This could be one of the method if you really need DR and BDR concept. So I am coming from that line.
I'm just gonna second this voice. Yes, we can specify everything. If you want to have an informational draft that somebody could implement or read, it's great. But this is, in my opinion, this is not something we should be specifying as a spec.
Actually, to just clarify one more thing, we solved this, like the first commenter, when he commented this can be alternative methods. So we solved this method today by sending a clockwise and an anti-clockwise copy, like using other methods. So there is already two copies coming to the receiver side, but not necessarily doing this method.
Sure. Any other questions?
So I have one question. So when people say that this doesn't need to be specified or it's not that important or so, do you feel that way about the working group, the current working group draft as well, or do you see these solutions being different?
I'm sorry, I wasn't paying attention closely enough when the first draft came along, so I'd have to read that one. So that's on me, my bad. But if that draft says the same thing, I would say the same thing about that. That this is this seems like a really small optimization for a one failure in a really long tree.
Yeah, so basically we have two drafts in pretty much the same space. We need to see, is there a need for both of them or none of them or one of them?
Okay. My vote is none, but without looking at the other one. But if we are to do it, I think it should be something that doesn't require any changes to the protocol because like it shouldn't change any hello. It should just work with the way it works and an informational, like you said. If anything, make it informational, but make it something that, because this feels like more of an implementation optimization.
I just want to add other thing on top of it is that in a normal production environment, as I said, you should have a link between R8 and R9. In this diagram, you're assuming that the best path for the R9 is on the other side. But it may or may not be true. What about if the R9's best path is also through the R8, right? And in that case, if your R8 goes down, your outage still remains the same, regardless you have a DR and a BDR.
Yeah, so it will totally depend on your network topology.
But that's what I'm saying. Like, if you're going to depend on the implementation side, there are other methods which can already solve this problem.
Sure.
So, okay, so I think we need to have more discussion on the mailing list to see what kind of interest there is in this draft and also maybe the existing working group draft, and see if people have thoughts on how useful they are or which solutions they prefer. So please send your thoughts to the list and we'll continue there.
Yeah, sure. So the next draft, next draft, it talks about PIM DR shutdown. So PIM DR shutdown is not exactly the shutdown, it's more of maintenance mode. So in real production network, when your PIM DR is going on the product maintenance mode, how gracefully we can hand over the responsibility to new DR. And again, this document is being presented first time, and we want to have more kind of discussion and feedback to see that how useful this could be in real network. And so today what happens if PIM DR is going down? So it could be because of maintenance, it's going down, and new PIM DR is taking over. This is the one case. Second case could be, which I have not specified here, I think. Second case could be when your new PIM DR is coming up and it is eligible to be a DR. When new PIM router is coming up in the network and it is eligible to be PIM DR. So any transition, when DR transition is happening, how gracefully we can do this. So in summary, what exactly we are trying to do is trying to solve it using our hellos. So whoever is the current PIM DR, it can send PIM hello with priority 0, and it will have new option of saying that, hey, I'm going in the maintenance mode, and it could be gracefully shut down or any info in that option. And current PIM DR will also make its assert metric to infinity. And why exactly we need it, I think it will come into the next slide when we talk about the hybrid mode, where some of the PIM router do support this specification and some of them don't support. And when new PIM DR election is done, new PIM DR will start building the tree, it will start forwarding, and as and when duplicate traffic starts hitting the previous DR, it will keep pruning all the tree states. And that was the reason basically we wanted to have assert metric as infinity, so that even in case when you are getting duplicate traffic, it shouldn't happen that by mistake the PIM DR who is going down wins the PIM assert, and it still becomes forwarder. So if you see in this case, we have 4 PIM routers, and I have specified their priority. And right now, the rightmost router is the PIM DR who is forwarding the traffic. And I am not showing the core this here to make this figure simple. And the router with priority 110, it wants to go down for maintenance. So now what exactly it can do? So basically it will send a new hello and with priority 0 and with new option as a GR. And once this hello is received by each of the neighbor, they will process and they will do DR re-election. And now between 2 routers who have same DR priority, the router and the leftmost becomes the DR, and it will start building the tree, and it will start forwarding multicast data traffic. So once if you see the data traffic start hitting back and the 110, so basically it is kind of, you start getting traffic on your forwarding interface, and that's when assert will kick in, and 110 should prune its complete multicast traffic. And what will happen if some of the router don't support this specification in the network? And so there are two cases. If the router who doesn't support this specification is to be PIM-DR, then exact same step should be followed. And if the router who doesn't support this specification cannot be a PIM-DR, it doesn't need to worry, because there is no change needed. And the other option, the next third option is if the PIM-DR itself doesn't support, the new PIM-DR doesn't support this specification, basically it will start forwarding right away, and assert mechanism will take care that the other router automatically prunes the data traffic. Yeah, any questions, feedback?
So I'm a little confused by the assert part, because usually assert is for transit lands, for joins going from router to upstream routers in a transit LAN.
Mm-hmm.
Asserts don't usually happen on the LAN with receivers. So are these PIM asserts?
Yeah.
Okay. All right. And are they needed? Or why are they needed?
No, so that is the one option to basically detect, because if you don't do this, so it's kind of timing mechanism. You have to do some kind of timing, right? So when one guy is leaving and another guy has to take the role.
Mm-hmm.
So there were a couple of other options which we thought about. One of them was timing, but you cannot make sure that the one is leaving at the same time when other one is picking up, right?
Okay.
So assert was one of the mechanism which we think, but yeah, if you think there are some alternate ways, yeah, feedbacks are welcome.
Why can't why not just have the guy who's going down just send out a lower metric without any special hello mechanisms or anything? Just send out a lower DR priority, and then he would lose DR ship, somebody else would take over, and then they would take over from there. Is the assert resolving the switch from one to the other, or what?
No, so this is definitely, that is one option to do it, but this is to avoid any traffic loss. So basically it's kind of, you are saying that right now you are DR. When you say that now I'm not DR, you lower your metric to 0.
Mm-hmm.
So you have to give other DR to build its own tree and then start forwarding.
Okay.
Yeah.
So what if I'm going to be a DR, I continue, if I'm a DR, I'm undergoing maintenance, I send out, I set my DR priority to 0, but I keep forwarding until I see somebody else forwarding, and then that's when I know stop doing that.
Yeah,
would that be a mechanism?
Yeah, that could also be one of the mechanisms, yes.
I mean, again, this seems like an implementation thing, or at least, at the very least, I think it could be specified for informational purposes, but sure. I think it's better than having a new hello option that then you have to worry about, do implementation support it or not support it, and I think it'd be easier to just do this without changing the protocol at all.
Sure.
So just want to clarify, when the assert is happening, the DR, right, the other DR is coming active. So you are assuming that the DR will keep forwarding the traffic, and there will be basically 2 copies coming?
For transient time, yes.
So just to let you know, in the world, if you go look at the receiver side, they don't take the 2 copies of the multicast very well. So you're going to end up having an outage anyways.
Okay.
Yeah, so I guess I'm a bit involved with this draft myself. So not as a chair, but as an author. So you basically have the choice, right? When you transition the DR role, either you accept some gap in the packets, might drop some packets before you get the new forwarder, or you try to make it smooth like this, where you might get duplication of a packet or 2. So it's kind of like depends on what you prefer, really. It's really hard to make sure that you have no drops and no duplication. You kind of have to choose one or the other. But yeah, the issue with asserts is basically the guy that is becoming the new DR, he adds this interface to his OIF list. So if the old DR keeps forwarding, he will see like, oh, I'm getting a packet on my outgoing interface. I should send an assert. Then the previous DR, if you don't do anything special, will respond by also sending an assert and might actually win the assert and supposedly be the forwarder, even though he's going down. So there's so to make this work, you kind of want some small adjustments to how asserts are handled.
Can you bring up that picture again? What if, as the guy's going down on the right, what if he sends his join to he knows who the backup DR is. What if he sends his join to the backup DR? Would that work? And then he can prune his branch. You eliminate duplication, because that's a great point, that duplicate packets have proven to be far worse than lost packets for certain applications, not video, but it's usually the financial guys have all kinds of problems with duplicate packets. So then you can kind of get your make before break type behavior.
So basically you're saying the router with 100 priority is supposed to send join towards 110?
No, the other way around. The guy who's 110, who's going down for maintenance, sends a join to the 100 first. Then the 100 guy gets join state, and he joins it. And then the 110 guy drops his DR priority to 0. Then you can eliminate that gap. Though it's creating a different gap, but it probably a shorter gap. And it.
Mike, please.
I mean, typically, if the backup gets the join and he's not the DR, he's going to not pass it on, right? So you need to tell him at the same time.
Why not? Well, because let's say 110, his upstream link dies. His shortest path could be through one of those other 3 routers. So he could be sending a join to one of those other 3 routers.
Yeah, the only problem is, you can do that, but you still have the assert problem, because the guy that receives the join, if he sees traffic that is still forwarded by the DR, he will assert. So you can do kind of make before break. The thing, is in the usual scenario, when the routing changes, the assert metric will be better for that other guy, so he will win the assert. But if you send a join, even though you are actually the best one, but you still send a join to the other guy, then you will do assert and he will have the lowest metric. All right, so I think for this one as well, if you have more comments here, that's great. Otherwise, we would like to hear from you on the mailing list. The list is really quiet in general, but hope some of you can comment on this. I don't think Ashutosh is here, so I think I will present it. Where is it?
Thank you, Makamana. Are you going to resume now? Okay, thank you.
Yeah, I'm one of the co-authors, so I'll do this one. So the problem we are solving here is when you build build a PIM tree, RPF tree, whatever you call here, you basically send a join to your RPF neighbor. So you look up in the RIB to find who is the next hop towards the source or RP, and you send a join there. But if you are using RFC 5549, when you look up a v4 address, your next hop is a v6 address. Yeah, your next hop is a v6 address. So then you kind of expect that you will have a PIM6 neighbor you can send a join to. But for a v4 S, G, you actually want a v4 neighbor. So the question is, in a way, you have your IPv4 PIM neighbors, you have an IPv4 S, G, but unfortunately your next hop is a v6 address because of C5549. So you want a way of finding out which v4 PIM neighbor has that v6 address, so we can send v4 join to the right v4 neighbor. And as it turns out, we have the secondary address list option in RFC 7661, 7761, which takes care of this problem. The only thing is, in that RFC, it's expected that the address list is the same address family as the base protocol. So it's a before hello, you expect it to be a list of v4 addresses. What we want to do is the exact same as that hello option says it should do, except it's a different address family. We want to list v6 addresses in the hello so that we can know which v4 neighbor to join to. So we agreed in the working group like 2 IETFs ago that this is a useful solution. It was adopted, and nothing has happened with the draft the last 2 IETFs because we haven't got any further input. So we authors basically believe it's ready for last call, unless people have any concerns about the current draft. So it's a very simple draft. It's informational and saying, oh, we can use the existing address list option to solve this problem. And it just says that in that case, it's okay to use a different address family. All right, so as an offer, can this go to last call, or what do the chairs think?
Yeah, so let's poll the room. So who feels that this draft, this PIM working group draft, is ready for working group last call? So I see 3 hands. Very good. Do any of you feel that it's not ready for working group last call? Okay, that's 0 hands. So we'll ask the same question on the list, and hopefully at least those 3 people will respond. And thank you. Yeah.
All right, great, thanks. Yeah, so it looks like we will have several drafts coming to last call, but before the next IETF. That's cool. All right. Let's see. I have one more draft.
User this.
Yeah.
Again. P2MP use case. Oh, it's great.
All right, so I have this draft that I've been working on with Alvaro. So it started out as more like a process kind of thing, IETF process thing, where we realized that there's several RFCs using PIM reserved bits, basically saying that some of the reserved bits should be used for specific purposes. Like BSR 5059 talks about using a specific bit to mean no forward. PIM Binder 5015 uses 4 more bits for that purpose, for some other purpose, and so on. But those RFC never updated the original RFC 4601 that says those bits are reserved. So we kind of wanted this one document to update the PIM sparse mode RFC and say, oh, these bits are not treated as reserved for these message types. Also, we figured it's good to have some kind of registry where people can go and see for which messages are which bits used. So that's one thing that this draft does. The other thing this draft does is trying to extend the PIM type space. So you see down here for 13, 14, and 15, say it's extended type. So we're trying to find a way of extending the type space, because today we only have 16 message types and we already have used 12 of them. And we think this could be one way of extending the space so we get a lot more options. So the proposal is that this is at the top here is the regular PIM header that says that we have 8 bits that are reserved. And as I was showing, some message types actually use some of these bits for certain purposes. And what we are proposing is that for message type 13, 14, and 15, we say that the 4 leftmost reserved bits, actually I can use that pointer, I guess, maybe. Maybe not. Oh, yeah. So basically we are saying that for those 3 message types, we take some of these reserved bits here and make them form a subtype. So the idea is that for, it's like message type 13 would not be assigned to one specific protocol, I should say, but rather we would, for message types like 13.0, 13.1, and so on. So each new use of whatever PIM messages, each new PIM message we define would use some subtype. So 13.0, 13.1, and so on. So that means that existing implementations, they ignore these types because they don't know what they are used for, right? But when you implement in the future some PIM message, say 13.0 or something like that, that means that you will have to implement code that also looks at this field here to distinguish the message types for 13, 14, and 15 so that they can have a different purpose. This is exactly what was done for PIM-Binder. PIM-Binder has several new message types, but instead of using like several PIM main message types, it just used like a subtype for each of them. So it's basically saying that instead of using just the 4 bits we have for PIM message types today, we will, for 13, 14, and 15, include 4 additional bits as part of the type. So it's a backwards compatible way of adding basically 48 new message types, or I should say adding 45. We are taking 3 messages away kind of and adding 48. All right, so yeah, I would like to see if people have interest in this, if it should be a working group document.
Any questions for Stig? Any interest in this work within the PIM working group? I see a hand up.
Some curious people didn't read it, people don't care, or have no opinion, or it doesn't matter, or
Okay, let me just ask the question. So,
yeah, maybe I can ask.
Okay, go ahead. Sorry.
One question though: do people agree that we should look for ways of extending the PIM message types? Do we need potentially more than 3 more PIM message types in the future? Is it like we don't need to solve a problem, or this is not the right way of solving a problem?
Today, 3 seems a lot. So, like solving future problems today when we have a way to still solve them in the future.
Yeah, so I'm basically trying to solve this before it's too late, right? Because if we assign them the remaining PIM message types, then we don't have an easy way of extending it.
Yeah, that means that we would have to assign all the bits. That means 90% of people in this room would have to stop coming to PIM for that to happen, if not 100%. So the chances of that are not high. that, and once we add this, then we have to, it's a cascading make work effort for a future that may never happen. It may, but it may never. So if somebody comes and hears my messages, I'm missing, let's fix it. But let's extend it.
Yeah. But yeah, just to clarify the way this proposal is today, if this were to become an RFC, then there's no implementation work needed right now. But if anyone wants to implement one of these future options, that future PIM message types that use this stuff, then they will have to implement parsing and checking all those bits. So you could say, even if we do make this an RFC to be prepared for the future, we don't actually have to implement anything until the future comes here and we actually need those new types. So.
Do you want me to ask about working group?
Okay, sure.
Okay.
I'm done here.
Okay, so we've already said one person raised their hand. I think this kind of work would be interesting in this working group. Let's just ask the question that we'll ask on the list, and that is, who here feels that this is a draft that we should adopt? Okay, we have two hands. Thank you. Who feels that this is a draft we should not adopt? Okay, so no hands. There is a comment, though.
Perhaps the best question really is this a problem we should be solving?
Yeah, that's a good
You may
question.
not necessarily agree with his proposal, but there is an issue.
Yeah, no, I agree. So that's what I sort of asked at the end is, I'm curious, do people think that this problem needs solving or not?
I think the normative word there that I was missing is now, right? So I think we may easily procrastinate on this for much longer.
Yeah, but okay. Yeah, you guys may not agree with me, but at least our options, we will have less options if we start assigning those remaining types without doing anything.
I agree with the now comment. If we had a problem to solve now, 100%, I like what you're doing. If you ask me, is this a problem that we need to solve now? I would say no.
Yeah, so I'm happy to keep the draft, just keep refreshing the draft. And when we actually need one new PIM message types, I can ask, do we need this?
Yeah, I think I agree with the same thing. Like, if there's no problem to be solved right now, then why assign these bits to something? There might be a better use case or a better problem to be solved in the future if it becomes an RFC. Then these bits are gone, basically, right? And coming from another section, they are saying that there's no undo. Like, if it goes into a draft, there's no going back. Like, there's no unadopt. We don't do unadopt, right? So if you don't do unadopt, then it will basically mean even if we are on a wrong path, we'll continue on a wrong path. There's nobody wants to correct, nobody wants to admit that we have made a mistake.
Alberto, not speaking as an author, speaking as the routing AD, the fact that you adopt anything doesn't mean that you have to publish anything. You may run out of interest in whatever you adopt and never publish it, or you can change your mind and do something different, right? So the fact that it's adopted doesn't mean that you're stuck with anything, not just for this draft, but for any other draft that has been already adopted.
Yeah, there's, for example, the parking position for drafts as well that I saw on Data Tracker, right? So there seem to be all type of things, but what the minimum to do is you can even let it expire, and every time somebody comes up with a new draft and wants to take a code point, then bring this really up again, and then maybe people that want the new draft are also a lot more interested to take looks and start having opinions.
Yeah, at least my hope is that when next time someone actually gets a code point, they won't actually get like type 13, but they actually maybe get something slightly different.
And that's a decision that the working group come up with. Like, yeah, we want this progress, but sorry, we're going to make this pending on getting a new subcode point from the extended space.
Yes, I guess the question is there any way anybody could do an end run around this group in which David Allen Erickson. And in which case, then, is there some way to go to IANA and change the allocation policy for
Right.
the last few bits, just to say it has to come through here?
Right. No, we have full control. There won't be any assignments unless there is an RFC, and it has to go through this group, generally speaking, at least. Right.
Right, Alvaro Rutana. So if you go to the first slide, you started saying that this was sort of a process thing. The process being
there's
that,
two different problems being solved here. So I have a
Right.
question regarding that.
right, I just wanted to point that out as well, that
Yeah.
42, whatever the number was, 4601 and 7761, neither one of them say how to assign these bits. And even though they don't say that, 5059, 5015, and 8364 actually took bits from there. So yes, theoretically, there is no way for anyone to assign those bits, but we already did, right? And yes, those documents went through this working group, but in theory, if someone else from, say, a different working group decides to assign a bit there for whatever reason, I don't know why, the only way to stop it would be if one of you reviews the document and points that out. If the AD, me, or someone else finds that out and figures out that there's no allocation policy in the registry and decides to stop it or whatever else. For all those three RFCs, no one really noticed until it was too late, right? And so, that's the point, right? That there's two problems here. One is the problem of just updating the registry. And so, yes, we could write a one-page document that says update the registry to say this, whatever we decide, specifically required or IETF review or whatever we want to do. But then we thought that while we're doing this, we might as well just do the right, well, I'm going to say the right thing and define what the bits are actually used for in the future, not just change the allocation policy. Because of course, if I'm going to use the next bit, I'm going to want 13, right? I'm not going to come to the working group and say, oh, no, I want 13.1 or whatever, right? I'm going to want 13. And then we're probably going to say, well, okay, let's wait till 14, and then we're only left with 2 bits. And then, so in any case, we probably have to do something if it's at least to clear up what the allocation policy is.
Yeah, so at least one option is if the working group don't think we are ready for extending the type space, is to revise the document and just have a document defining the registry. Just get that part done.
Did you foresee anyone to add subtypes to existing types?
No, don't want to do that because that's not backwards compatible, right?
Well, I mean, I guess some of the some of the things we talked about earlier were like modifying hellos and setting different priorities, and you can.
Yeah.
And so I'm just suggesting that maybe you could do that sort of thing.
So that's why I'm wanting to do this now, because I'm hoping to avoid that happening. The problem is if an implementation is not updated that doesn't know about subtypes, right? It will just ignore the restored bits because that's what restored bits means, and it will then go ahead and answer even if its message was not.
I guess so. I was kind of seeing that you could have an ACK subtype for the new subtype that you have, right? Because you got all that extra space then.
Yeah.
So you can say, do you support this feature, and you can.
Okay. Right. Yeah. So just okay. One thing I want to say is, the point is if the version here says PIM hello, right? If someone doesn't know about this subtype, they will. If the type here says hello, a router that doesn't know the subtype would then think, oh, this is an hello, and it isn't. But yeah, you could. What you potentially could, at least for messages that are linked local, you can have a new hello option saying I support extended types or whatever, right? And just say you only use the new type of messages if all the routers on the LAN say they support that. Yeah. Okay, so I don't know. We could take it to the list maybe if that's okay to see if people are interested, or I can revise the draft to just create a registry and not worry about type extension at this time.
Your call.
Yeah. Well, if you can check for interest on the list first, that would be cool.
Okay.
Okay.
We got Greg now. Get queued up, Greg.
Okay, I think you're unmuted now.
Okay, I'm ready.
All right, cool.
Oh, there it is.
Thanks, God.
All right, we are ready. Can you see the slides yourself? Or?
Yes, yes,
Okay.
thank you. Okay, so we presented this in London, and the proposed solution is to use BFD for multi-point network specification with the head at DR. So the DR, non-DR PIM-SM routers can monitor the well-being and availability of DR. Included in this proposal is extension to PIM Hello format, so that DR bootstraps non-DR routers by advertising its discriminator. That's because the specifics of multi-point BFD over multi-point networks does not use three-way handshake, which is a part of point-to-point BFD per RFC 5880, where there is no need to bootstrap over IP because each of the routers exchanges control messages and thus knows remotely advertised discriminator and can do demultiplexing based on that information that is returned to it by its peer in a packet in a field of your discriminator. Another particular feature of BFD for multipoint, as it uses the demand mode to begin with, the multiplexing packets are not, as I mentioned, on your discriminator value, but on a combination of the source identity, multicast tree, and my discriminator value. So that's why it's important to do the bootstrapping before their tails can listen to the head on a BFD session. So that all was discussed in the original version. And before the meeting, we had very good discussion on the list, whether it can be extended and used optional, can be use cases for other than monitoring DR on the shared media. We think that there might be value for monitoring BDR in the same scenario, though the actions would be somewhat different because electing BDR may be follow a different process. But if we go for the next slide.
Next slide.
I'm sorry for my dog. I have no control of him. So this is the format of how we propose to exchange their discriminator information. And we can go to the next slide. So the update is that this can be optionally used by other than DR to monitor in other scenarios. So that is open for discussion, and I believe the stick suggested it could be used for the assert. Another interesting functionality that monitoring well-being in a demand mode gives us that the BFD session can be used to signal that the router is not longer, or the functionality that we associate the BFD session with is not longer available. So, for example, there was a question in an earlier presentation. So, what if upstream router fails? How it can affect their roles and behavior on a shared segment between DR and BDR. If on a shared segment we have BFD session, then DR can take the BFD session down, thus expediting the switchover between the distribution tree. So we can discuss other scenarios and definitely bring them into the document. So the next slide. We welcome comments. We have very good discussion, and everybody is welcome to join. And we would like to ask working group to consider adoption of this document.
Any comments, questions? So I know there are several implementations using BFD for PIM today. So this is just, I was going to say, if you already have BFD for PIM, this is pretty much similar, right? The only difference is that you don't have a full mesh, you have, or you utilize multicast on a local link, right?
Right, and that is one probably benefit. You don't have to do full mesh of point-to-point BFD sessions, and another is that you don't create unnecessary state on DR, because in this particular scenario, it's only tails or non-BDR or non-DR nodes that are interested in a state of DR. DR is not interested in state of other nodes on a shared link.
Right, because BFD is normally bidirectional, but this is more like a one-way thing, right?
Yes, precisely.
Yeah. Yeah, I'm also realizing, there are several implementations of PIM BFD, but there's no document describing it at all, I think, existing document.
Yeah. Actually, one note that I can make that their BFD for multi-point networks specification is in ISG last call, and together with their another version with their what we call active tails, so that when tails have an option of notifying the head of the continuity, so whether they receive BFD control messages or they detected a failure.
Right. Yeah. Yeah, I guess. So, how many people have read this draft? Raise your hand if you read it. 2 people, so that's not too much. Who thinks we should adopt this draft? I guess. Yeah. Okay, 1 hand. Anyone opposed? Yeah. Yeah. I'm actually. Yeah. I'm supporting adoption myself. So 2 people for adoption, I guess, and none against. We'll have to take that to the list, I think.
Okay, thank you.
Yeah, thanks.
Thank you. Okay, so while Dave's working his way up here, I just wanted to give a brief background on this draft being presented here in PIM. So multicast is not, and you may have your own take on this, Dave, but so multicast is not currently specified within the Spring Working Group for segment routing. It's not part of their charter. There was a recent rechartering discussion, and as far as I know, multicast was not included as part of that rechartering. So we've agreed for now to address, since we're protocols for IP multicast, we agreed to look at these types of drafts that have to do with multicast and segment routing. And there's been some different, there's been in the last IETF, we had a presentation with regards to beer and segment routing. In this case, Dave is going to introduce another solution for multicast and segment routing. And that's why he's here. Is that about right?
Close enough.
Okay.
Yeah.
Yes.
What about the tree sit?
Say that again?
Tree sit. What about
Tree SID.
I don't know if it's proprietary, but it's a scheme that Cisco was showing at Cisco Live for segment routing with programmed point to multi-point replication labels.
Is it being discussed here?
I don't know.
Okay.
I'm calling Nokia. I don't think that 3-seat was ever brought to the IETF. I think there are some extension for the BGP SRTE that might be used for 3-seat, but my understanding is it was never brought into the IETF. Proprietary or not, I don't know, but you're right. It is out there.
I believe it is described in a draft, but the draft, I think, is at 00, and they did not ask for agenda time. But that's my supposition. I just know I have seen it mentioned, I think, in a policy draft. Okay.
I thought it was. Sorry. I thought it was part of the. It was briefly explained in the BGP SRTE draft or something like that. But I don't think it has a draft of its own, unless I'm mistaken.
Okay, so to be clear, this is not TreeSID. Okay, so what is this draft about? It's about using computation to determine the routing of a multicast segment, which I would say is probably analogous to a TreeSID. This is for an MPLS-based SR network, and how we can use tunneling using node SIDs as part of the tree construction. And this could either be a distributed or a centralized control model. If it's a distributed control model, for example, the expectation is multicast membership would be advertised in the IGP, and when combined with knowledge of the topology, a multicast tree can be computed by a node, and it can figure out its role in it, including whether it would be tunneled over or not. So the draft describes the couple of tweaks to the terminology that's required to incorporate this concept into segment routing, gives an overview of the overall approach, describes how to do loose or explicitly routed multicast distribution trees, provides an algorithm for tree construction, and goes into FIB installation procedures. So the motivations. The biggie in doing this was to reduce the amount of state in the network, because multicast state can rapidly dwarf unicast state. In a previous life, I worked on shortest path bridging, and in any sort of network design that I worked on, the amount of multicast state very quickly blew out the unicast state in terms of the FIB construction. To give you an example of this, to cut to the chase, for most multicast trees that are flat, the amount of state ends up being some function of network diameter. Now, if I'm using the existing mesh of node SIDs that is already there, and I only have to install state at the root, at the leaves, and any intermediate replication nodes, then you can quickly figure out that in absolute worst case, the amount of state is going to be 2 times the number of leaves, because that's the number of additional replication points I would need in the network. And that's completely independent of the network diameter, whether it's 3 nodes in diameter or 1,000 nodes in diameter. So that is a rather massive reduction in state. Next chart. The other motivation is to leverage the MPLS data plane and segment routing as much as possible. And this notion of being able to use tunnels as part of the tree construction is using the SR-MPLS data plane in ways that, for example, PIM or MLDP could not. And the other motivation is to be able to implement multicast where beer is not technically or economically feasible. So I'm looking at some of the lower end merchant silicon type chips where it is not likely they are ever going to be able to implement beer on those particular chips. So that's in terms of the continuum of solutions, you can say beer is completely if beer is completely stateless and PIM is completely stateful, we're coming in somewhere in the middle in terms of what this means for the network. So the approach, the draft describes an architecture where the tree is a hybrid of the roots, the leaves, and the replication points, and this is all interconnected with tunnels. And the routing of the tree is determined entirely from information in the IGP. This could be in a distributed model. This could be using an SR controller. I don't particularly care. These are all valid solutions. It gives you a lot of benefits. First off is it's a minimum amount of messaging to converge the network. If the node knows all the multicast membership and the topology, and there is a topology change, each node has sufficient information to be able to fully converge the network for both unicast and multicast forwarding. So it is only the topology change advertisements that are needed to fully synchronize the network. I've already gone into reducing the data plane state. It will actually reduce the bandwidth requirements versus a straight IGP-derived tree using joins and things. And there's a specific and serendipitous reason for that. That's part of the approach. Unicast convergence will provide recovery for most failures. For example, if I'm in a network with a large number of sparse trees, then most of the time a node or a link failure will not actually affect the forwarding of the majority of the trees in the network, or even the trees that potentially are transiting or could be transiting that. Unicast convergence will fix it, and that's another property that's taken advantage of. So, an example tree that we can sort of barely fit onto the screen here. I've got a root, I've got 4 leaves, I have a multicast SID that I'm using as the basic unit of tree construction, and you can see where I'm using the node SIDs to actually tunnel, so that, for example, node 14 did not need to install state for that tree, despite the fact that node 14 is transited by that tree. So the net result is I've got a total of 5 nodes that actually have to participate in the tree because they're leaves or roots. They're either going to be sending information or explicitly receiving it. And to fully implement that tree, I only needed to install state in nodes 5 and 12, and all the rest of it took advantage of the node SIDs that already exist and are maintained by the IGP doing the unicast solution. So in sort of the big picture, I have a reasonably sized tree, in the example, a relatively small network diameter, and the net result was the converged solution only involved 2 extra nodes having to add state. Versus, say, for example, with a PIM solution or MLDP, it would have been at least 5 nodes to do that. So you can see how the amount of state required starts going down quite dramatically. Now, there's certain attributes that are very desirable for the tree. What I want is either a minimum cost.
Sorry. So the the state reduction comes from the fact that you're doing automatic tunneling over nodes that either don't support the feature or that basically aren't needed right now as a replication point.
Yeah, it's more that they aren't needed right now. When at the start of the day, everything could be a candidate for to be a part of the tree, and you
it might not
progressively
support the
eliminate
feature,
them.
right? That might be another reason why.
That could be another reason for tunneling over them as well.
Tell me if you would rather have the questions at the end, right? So, but other than that, it's easier to. So what's the reason to call this, let's say, segment routing as opposed to MPLS? Is there any particular, functionality that makes you, other than it sells better with the name SR?
It actually would work with MPLS, but we were originally starting out with the multicast SID as a global value.
Okay.
And drawn from the global label space. So that actually was kind of the genesis of applying it to segment routing.
Okay.
Given what has transpired since this work was originally done to allow a global SID to map to individual nodes having their own label spaces that do not necessarily overlap, it would be quite reasonable to suggest this could also work in MPLS.
Right.
Ilya, Mellanox. So now try to understand, if I need to change dynamically this tree, for example, I need another node that should join between 5 and 11. What does it mean? It means that I need to make multiple changes in states in multiple nodes?
Hang on, where's 11 on this? So if I haven't, say, either 0 or...
Say, for example, we have 9, that is some also on the path, and I want to join 10 to this tree.
Right.
So it means I need to program 9 and 5.
Most likely, yes.
And it means I need to program them in a specific way, otherwise I'm blackholing my traffic.
Correct.
Okay. Thank
you.
Yeah. So just to understand, are you trying to leverage on the unicast SR to make these trees, or like to me it looks like right now what's happening here is that like on node number 5 you have 2 unicast tunnel SR tunnel that when you come to 5 your traffic will be ingress replicated into these 2 tunnels. Is that the case, or did I get this wrong?
It's not English replicated. 5 would be doing a replicate and then encapsulate.
Okay, but these tunnels are completely different tunnels that are being presented via different SIDs.
They are the existing node SIDs that would be there as a result of the unicast connectivity and segment routing.
Okay, thank you.
They could be just as easily FEX in an MPLS network.
So I think one comment is, yeah, definitely I believe that we do need a SR type of solution for multicast and segment routing. But right now I see 2 different methods on the table that they're kind of competing with each other. The tree seed where a seed ID kind of represents the entire tree end to end. And then you have BGPLS, BGP SRTE that sucks up the configuration of the network and you program it. And then you have this method. I would imagine they need to go into the same group to see the cons and the pros of each of these, and one should be chosen, or if 2, it doesn't matter. But I kind of feel they're kind of competing with each other.
Yeah.
Yeah, and I was specifically asking about MPLS versus SR because it would be lovely to figure out some good technical reason for one or the other instead of just wait a second, SR is the best buzzword today, that's why we must use it, right? So the technical reasons to make one choice or the other would really be good to document, right?
Yeah. Okay. So the use of tunnels would require either a minimum cost or near minimum cost tree in order to be sort of ECMP friendly. And what I mean by ECMP friendly is I'm trying to avoid making sure that under no circumstances I would get 2 copies of a packet on any single link. So I'm trying to avoid any possible requirement for logical multicast. Now, there is a tree construction algorithm in the draft as to how you can actually produce those trees and do it with a relative minimum of computation. And serendipitously, the algorithm is also a source of improvements in bandwidth efficiency, because it will tend to ensure that the replication points are shifted towards the edge, closer to the leaves in the network. And that will actually drive up the overall efficiency compared to, for example, PIM or MLDP, where it's relatively random whether they actually pick the best and closest point to join the rest of the tree. So there's also the possibility for loose or explicitly routed trees, where a loose tree is composed of a single multicast segment with a SID, where only the roots and the leaves have been specified, and the connectivity between them is filled in as a result of computation on the database. We can also have an explicitly routed tree, which is basically a concatenation of multicast segments where the roots, the leaves, and the waypoints have been specified. And which means I can then engineer a tree to any degree of granularity that I want. So if you're having a sense of deja vu, this has been presented before. The last time was in IETF 97. It's been brought back because, as it turns out, there actually was quite a number of people who were interested in this work, and they just weren't provided with the vehicle to express that at the time. So the current draft, it's updated the terminology to align with the current state of SR-MPLS, went through it and did some editorial improvements, added a section to describe the motivations, or at least some text. There was some improvements to the algorithm description, because, I mean, this algorithm was actually prototyped, and actually one interpretation of some of the optimizations in the prototype that were reflected in the text actually made it a bit confusing, and I cleaned that up. And it now offers some thoughts on SR controller operation. So it's sort of a new improved over the last version that has been presented, for those of you who may remember it from back then. So now, to get to next steps, of course, we want to collect feedback. We have some planned updates to the draft in terms of there are some improvement to the FIB installation procedures that are envisioned. I want to see if there's any changes to the draft required to bring it up to the current state of MPLS friendliness in terms of mapping block offsets, etc. And as been noted, this also could be applied to MPLS as well once that's done. And in future drafts, we'll be bringing forward the required IGP extensions. We did do a first crack at that back in the IETF 97 timeframe, how to interwork with existing mechanisms. And we are pursuing standards track, of course. And as Mike explained, there's a reason why we're doing it in PIM, and that's because it's not currently in the segment routing charter. So
it won't be for a while, it doesn't sound like.
From the sounds of it, yeah.
Jeffrey Zhang from Juniper. So when we talk about Spring, the main advantage we're talking about is that it does not have a per tree or per tunnel state in the core. Here, we still have the per tree state in the core. It's just that on those points where you don't have replication, you don't need that state anymore.
Right.
And if I understand it correctly, you still have to flood the group information everywhere. I think that's even worse than before.
But you're talking in the IGP, or?
Yeah, yes.
Okay.
Right. So this does not really, in my mind, it does not really fit the Spring philosophy. That's one comment there. Another thing is that for Spring multicast, we don't really need one solution that fits all situations. Quite a few of us have actually contemplated writing an informational draft on how to do multicast in a Spring network. I think the best, in my view, the best would be to choose whatever suits you best. So if you could do beer, that would be the best. If you don't mind to use the traditional technology, just go with that. Because in some situations you do need to use the traditional technology, as long as you don't mind maintain those states. And then finally, if you really just want to remove another signaling protocol, yet you still don't mind having the per tunnel state, then just use another way to set up the tunnel, the tree seeds, however it is set up. That is just one way to do that. So
you realize you are giving me a staggering long list of things to reply to.
I think he has only 4 labels stacked there.
Okay, so I mean, in the spring charter, one of the statements it says right off is that it does not want to modify the data plane of the existing technologies that it's using. And so I saw this as about as close as you could come for multicast while preserving the single control plane paradigm. Because, you know, I've checked with the vendors, this can be done with the existing MPLS stuff now. I think that is useful. As for whether or not you end up with path state, you already have the concept of the binding SID, which to me is simply a rather cute end run around this, in that the binding SID itself locally does translate into a potential series of local actions that have been configured. So, you know, I don't want to get into a philosophical discussion about this. I sort of look at this in terms of, if we say we don't want to change the data plane, and hence this can be supported today, and we want to go with the simplification of the control plane that's inherent to segment routing, then this is about as good as it gets.
Okay. So one key follow-up point is that this could be one solution of other many solutions, but using the wording framework, at least to me, it does not sound.
Well, if we're going to object to the name of the draft, I can change the name, but it's a framework for computed. So
let me try my attempt at sore loser whining here. So I'm doing BERTE, and so basically after the rechartering, when it became, you know, an adult working group, and basically the rule was only doing the forwarding plane things, and, you know, you're doing control plane, especially traffic engineering aspects, you must go to TEAS. So TEAS is responsible for the traffic engineering. I haven't followed up what really the current state of, let's say, Spring is with respect to you know, being able to define or do traffic engineering aspects by themselves, or how much TEAS need to do it. But I would really love, as a whiner, to have this be done consistently, and not only based on, you know, which working group you're going to, then randomly the traffic engineering aspects are going to be dealt with differently, right? So that just as one aspect about the traffic engineering part of this.
Okay, so I would take that as a recommendation that if I'm going to have a traffic engineering aspect in this, I should take it to TEAS.
I don't know, right?
Yeah,
so, I mean,
right.
I may just be the sore loser because beer is being singled out to do that, and Spring is doing their own traffic engineering, and PIM is doing their own traffic engineering. I don't know. All I'm saying is that was what I wanted to whine about.
Okay.
Here's my concern about this draft. It's multicast generally not easy. Everybody, I think, agrees. We try to simplify it. We put engine VPN for service providers to deliver. PIM is there. Then the whole problem of control plane. And okay, if I'm removing unicast control plane and putting segment routing, what will I do with multicast? We solved this with BEER. Yes, it changed a data path if you're using some, you know, lower-end hardware. That was true probably 5-6 years. Okay, no, not 5. How many? 3 years ago when we started BEER? That was more true 3 years ago. I think considering where the technology is now, by the time this will even come to a standard, I would say that anybody who deploys and thinks of control plane segment routing has a hardware that will be able to do either, which means why would we introduce something else yet for the same solution and add operational complexity or a solution variation complexity. That would, and I'm not arguing, if this was discussed 3 years ago, maybe a different outcome for a beer would happen, maybe not. But today, I think that should be a bar whether we should work on it or not. Why would we work on it?
Well, this was actually first discussed in IETF 95. And I'm not aware of anybody in the lower end ships even contemplating beer. In fact, I dropped it in 97 because my expectation is that beer was going to sort of go forward, but ultimately, and sort of a bit more ubiquitously than it has. And that hasn't actually really happened, which is why people have suggested I bring this back.
To the best of my knowledge, all major vendors will have working beer in hardware within the 12 routing vendors. Let me clarify. No offense to people who are not routing vendors who think they are. No offense meant, but like all those main guys will have a working beer in hardware. So, and again, I'm not arguing that technically can we do it? Yes, but does it make sense to yet introduce an alternative solution for something else and create complexity of and add again to the complexity of multicast? Because everybody we're talking about multicast, guys, and that's probably, it's like, oh, multicast, I worry to touch this, and adding options doesn't help us.
Well, actually, that same question probably could have been asked when MPLS was nearly done and Spring was brought forward. So,
yeah, MPLS is done. Yeah. Sorry for MPLS people. I've done some MPLS work. MPLS is done.
Okay. Who remembered Goldie Nokia? Strong words, but.
I don't mean disrespect, but like, as a new
So, but I do feel somewhat in agreement with Andrew. I think, segmented routing already has a bunch of complexity on its own. And now we want to put multicast on top of that. It might be a complex solution. That said, again, I feel that you're right. Some vendors will need SI3 seed or whatever it is that we want to call it to replace a MPLS signal PIMZ with something in a SDN type of level. If we can simplify this by saying like a seed represents the entire tree end to end, and take away that underlay unicast segmented routing complexity, then it could be a good fit side by side with beer to have an end to end SDN type of multicast solution.
Well, I mean, if you want to run it flat, you could just duplicate what was done for shortest path bridging. So, but that's, as observed, my experience with that is you get a significant amount of state once you get into a lot of trees, and the idea was, the nature of the proposal was to avoid that.
Okay, so I'm not sure if I understand that. So you mean that with this proposal, it is possible to represent the entire tree with a single seed?
Yeah, that's the idea.
I thought with the SR, each node will, so if you have a node that is trying to create the leaves, it's going to take two MPLS labels or whatever it is that you guys are taking the seed, one going northwise, one going southwise, like what you have exactly right there. On node number 5, you're using seed 11 going to leaf 11 and seed 13 to leaf 13. So that's two different labels.
I'm just stacking them. I'm tunneling.
You're stacking them on top of seed 5? So the entire tree is presented by seed 5? Is that what you're saying?
Say this multicast SID is SID 53. Then here the stack is 1153. Here the stack is 53, so I'm not following. Here the stack is 1353. Here the stack is 1653. So it gets to here, 16 is gone, 53 is the local interpretation
SID that is computed is to replicate on the 3 interfaces, and on 2 of those interfaces it's a replicating flash. Okay, got it, thanks.
We are running out of time here too, so
Okay.
just a quick question.
Okay, a quick question to our AD and maybe whoever was familiar with the Spring Charter updating process. So the multicast was not included in the latest Spring Charter. Is it because they don't think it's a problem worth solving now, or is it because they please work with other? We think it should be done, but it should be done in some other working group.
Thank you. That's a very easy answer. I don't know. Just for the record, I'm not the responsible AD for Spring. And also for whoever's taking minutes, I would have closed Spring. But the current responsible AD thought that we should recharter. I don't know why multicast is not there. Honestly, I don't know if it even came up in the discussion or not. Most of the discussion that I saw was around, just updating the current stuff. It came up. So
Multicast came up. I mentioned something on the list. There were several people that were interested in multicast, but the chairs thought that it was not necessary to work on multicast at this time.
there you go.
I just want to comment on that. Like, I'm from the operator side and would not agree with our guys from the vendor side that if the beer is ready in the next 2 years and the operators will go for a beer model only. So nobody's going to forklift and upgrade their networks in the next 2 years, right? There will be legacy devices still there, and we will need some other solutions other than beer as well. And even if you look at today, there's OSPF and ISIS running, right? Some people use OSPF, some people use ISIS. There's always better to have few solutions, like not 100, but at least few better solutions which people can pick and choose, right? And I think it's a very good solution. You should work on it. The only concern we have on our side would be that how would it scale on a large scale multicast deployments, right? Because it's a stateful method, and if it can scale for a large scale multicast networks, it's a really good solution.
Okay.
Can I ask a quick question? What you guys running for multicast now?
We run PIM.
Exactly. So two technology evolutions happened since PIM for delivery. No. It's another attack, and you didn't move for various reasons. So now we're gonna have another solutions and two technology evolutions. And will you move or will you not move? And like lots of choices. Okay, sometimes good, sometimes not the best.
So I'm not asking, again, I'm not saying that a lot of choices. I'm saying like at least 10 solutions should be there or less than 10. 100 solutions is also not good. So it's not a lot. There should be a few solutions to pick from, right? And people should have the choice to pick at least from there. It's a philosophy, it's a culture, like different teams approach it a different way, right? Not every network runs ISIS today. Not every network runs OSPF, right? So people make the choice. And vendors cannot. I would like to see the vendors not forcing.
Yeah.
Well, I would expect this to have.
Just again, guys, because seriously, the times when we could, as vendors, implement million solutions in hardware and software are gone. Those times, I think we all understand that. So we can talk technology and stuff like this, and then we're gonna come to you guys, and you're gonna say, "Well, I wanna buy it, but it has to cost that much." Well, it cannot cost that much because you wanted this and this and this and this. So in this world of building efficient things that do the work, let's pick up the proper technologies. Choices add to complexity. Complexity adds to cost. So it better be a reason. I'm just saying, I'm not saying I'm against choices, but better be a reason. And I do not see a compelling reason.
I actually would be highly skeptical of a ubiquitous forklift of the data plane, which is what I'm suggesting we might be able to avoid.
So the only thing I would like to say that, like,
Hey, Trillis,
if
we
we're going to keep it at that level, then we should
Holy
make a decision
cow.
that whether we're going to be working on one IGP in the whole world, we should discard like how much work is being done on OSPF and ISIS in parallel, right? Why we are spending time on two protocols at the same time? We should just discard one and work on one. Pick one as a group, right?
Yeah.
Okay, Trillis, you can keep talking.
This is evolving into a much larger philosophical
You can keep talking,
discussion.
but you may not be able to present at the end, just so you know. You can keep it going, but you're not going to have time at the end, just so you know. So your choice.
Right. No. So just wanted to say that on the forwarding plane stuff, that was one of the questions to us about MPLS, because I think we could keep the MLDP or RSVPT point-to-multipoint forwarding plane if we wanted to do something like that. But if basically MPLS is completely done and we don't want to, do new control for it, I have no opinion.
All right, very good. All right, so
There's always room for improvement. Yeah.
So Dave, we need to move on.
Yes, I
We
understand.
agreed that we would pull the list. We will do that on the list. Mike McBride from Huawei speaking. I think that this is exactly why we did recharter this working group some time ago to address protocols for IP multicast. So I think it should certainly fit within our working group. We may have to talk to Alvaro about if this working group does feel like it should work on this type of work, that we should maybe add that to our charters explicitly, but we can talk about that later.
Okay.
Any other comments?
Well, I would say we should see if the working group is interested or not. If there is interest, we can beg Alvaro if we can do it, but it's really up to us if you're interested in this.
After all my pseudo-negative, this is actually, I thank you for bringing it, because this is actually something fresh to talk about at multicast. So but which at the end is important. I think we need to have those discussions. What I'm trying to say is, guys, we need to have those discussions, but we should not be creating things for the sake of creating things. And I'm not trying to be controversial, but if you want to see how alive or dead is technology, look at the last 2 years of delivered roadmaps or product extension on major routing vendors, and it will tell you how active or not active certain technology is. We can be standardizing, the hell out of the stuff, but look at the implementations and what they are.
Well, my closing remark would be I'm not a masochist. I brought this back because there's a head wound that hasn't been filled, and it hasn't been filled since I originally brought this forward at IETF 95. So.
Thank you, Dave. Charlie.
Minus 5 minutes now, or?
Yeah, be as quick as we can. That doesn't work, I think.
Oh, yeah.
We'll need to press
True. Next slide.
down and not right.
Okay, so wait a second. Which stack was the reliable? No, I have two. So sorry, I didn't know in which order.
This is reliable.
Right. Okay. So there were no updates since 101. So I just wanted to do slides with a sales pitch why you shouldn't think this is just some strange optimization in the exotic parts at a far off island in PIM world, right? So, but instead, no, it's an important part in the puzzle to update our protocol landscape for the 21st century. Ta-da! Okay, next slide. Right, so what's the strategy? Sorry, these slides are all way too texty, so they're better to read on your own after you had way too many beers. So I think we want the best compromise, moving the industry to what we understand to be best working and what's best feasible. Right, and our constituencies are, the network operators, and evolving to be the best has, key third-party dependencies, and that's pretty much the problem between ASM and SSM, that enterprises can't easily move everything to SSM, right? So there's a lot of stuff where the application dependency says, oh, it should be an SSM application, but I can't do it, and then there are also great BIDR PIM ASM applications. Right, so until we basically make any progress, I would claim that, for many vendors, 90% of the money they're making comes from deployments where, ASM with either PIM sparse mode, intradomain, and or BIDR PIM is really crucial. And so we really need to make sure that we have for that option also an evolution long-term to say, here's the best protocols we want to use for that. Next slide. So, but one of the big leftovers that we have is MSTP, right? So we're going to get rid of MSTP interdomain if we adopt the ongoing call for, the deprecate interdomain ASM in MBOND. So if you weren't aware of that, please go to the MBOND list and say, I support that draft. So that was discussed an hour ago in MBOND. So that will have us get rid of interdomain ASM, but that doesn't allow us yet to completely retire MSDP because it's left over with a really well working solution, which is called the MSDP mesh group within a domain, intra-domain, to basically do a mesh group for PIM-SM. And so now the goal here is to figure out what can we do to replace MSDP in that role. And we've got RFC 4610, which is the PIM Anycast RP functionality, and it's just missing pieces where when I'm talking to customers, I'm always saying, if you want to have IPv4, MSDP in the implementations, in what's been standardized is better, right? It has a MIP model, right? It has limiters. It basically got reliability, congestion control because it uses TCP, yada, yada, yada. So in the end, what I think is we want to get RFC 4610 up to that level, which involves two parts of work. One is a Yang model with which we can do all these operational things like, limiters and, cache entries showing. All this stuff can nicely be optional. It doesn't have to be part of, the protocol specs, just, a local implementation part that vendors can put in if they want to do the Yang model. And the other one is reliability TCP. And this is where this draft comes in, because this is pretty much just saying we already have reliable PIM over TCP with all the congestion control that we need over, nasty links that we get more with wireless and anything else. And of course, WAN links where we have the PIM register between mesh group members running. They often also are problematic when we have, failovers. So, so this draft is pretty much adding port for the registers. The important case, I think, is the mesh group. It also gives us port for the DR to RP operations, which is great too, which kind of, to me, is second priority from the strategy perspective. Next slide. Right. So we would like, so this has been around for quite a while, right, this draft. So we would like to ask the PIM working group to adopt this document. Please go read it, what you think, right? The text for the technology has been fairly stable, right? This is the strategy, right? I don't want to talk about all these things here. I think that's the second slot, which we may run out of. So the main missing part in the text is really only add information about the strategy, which relates to why we're adopting, but not the technology about how it's working. That's pretty much done, I think, right? Obviously, there will be bugs that we find in the working group review, which is why we want the working group to run it. But that basically would then, in my opinion, then we add the Yang model for RFC 4610, and then we kill MSDP.
I think you're scapegoating MSDP. I don't think MSDP is the criminal here. I think MSDP is merely driving the getaway vehicle. The real culprit here is ASM. And I think you're blaming MSDP when you should be blaming ASM. And all you're doing is taking the stuff that MSDP did and moving it to other protocols. And I don't think that helps. MSDP, I think it's a scapegoat because it was given an impossible task and it does it. There is, okay. So where MSDP is bad is interdomain, right? Yes. But it's not because MSDP is a bad protocol. It's because it was given a task to do, and it did it. But it was an impossible task, or a not a good task that it should have never been given.
Yes.
Intra-domain, what MSDP is doing within a domain for Anycast RP, which is typically what it's used for, is just connecting your Anycast RPs together. There's nothing wrong with MSDP. It's perfectly fine. None of the things that we associate with not liking MSDP for is it abusing in an intra-domain world. And in fact, all you're doing is just making RFC 4610, all it did was make PIM do what MSDP did.
Yes.
And now you're saying, well, it's missing a few of the things that MSDP was doing, so let's add all those in there so we can completely get rid of MSDP. I don't think MSDP is the problem. Renaming protocols doesn't make things simpler. moving the same function from one protocol to another because it's a less popular from a less popular to a more popular protocol doesn't make things better. You're just renaming functions. So I think the goal of eliminating MSDP I think is misguided because MSDP isn't the problem, ASM is the problem. You're just scapegoating MSDP.
Okay, so thank you for pointing out that I may be too offensive, right? So, but let's say technically, right? So in the first place, yes, I do think that intra-domain PIM sparse mode with an MSDP mesh group is a very successful deployment model, right? Very well working, and it's basically the best way for an enterprise to basically set up a rock-solid multicast that gives you shortest path trees and everything that you need to use for your stupid ASM application. However stupid they are, right? That's basically not the point here. We just have to recognize that we can't have our customers in the enterprise be the victims of the fact that they can't impact their applications, right? So that's basically why I want to have a well-working and also good standards track solution, and one that doesn't only work for v4, right? Because that's the problem of MSDP, right? So yes, I could obviously go up and do an MSDP version 2, which is basically throwing out all the interdomain stuff, right? And then basically add IPv6 signaling elements to it, and I would get fairly similar. But then, of course, I have basically, some good inconsistency between the port that I have for my join and prune messages in PIM, and then this crazy historic message format that I have in my MSDP SA messages. So it gets me the same stuff. It's just very inconsistent, and I would want to do a new Yang model anyhow, right? The IPv4 MSDP MIP only doesn't help me these days anymore. So that's why I'm saying it's technically the better alternative than trying to revive MSDP for IPv6 intradomain only.
Let me just add that we do have a draft for an MSDP Yang model, and we would like input on that.
Okay.
Yeah, and in the case of v6, we determined we don't need MSDP for v6 because MSDP was doing two things, one interdomain and one intradomain. Embedded RP gives us interdomain, and 4610 gives us intradomain. I guess your point is it gives us intradomain, but almost not as much. There's some things missing that we want to fix to get 4610 to the level of functionality that
the embedded RP is just a very IPv6 specific management rule, right? That basically have you, when you're doing v4 and v6, come up with totally different things, and doesn't give you the same amount of resilience that you get with multiple simultaneously active RPs, which is what the mesh group does, right? So it's still kind of the best resilient solution that we have for ASM.
Well, you still have 4610 for intradomain Anycast RP.
No, but I'm saying that solution doesn't give me the reliable TCP connection that basically work well over WAN links when I have failovers, and I get this burst of 10,000, SAs or register messages, however I want to call them, right? Mm-hmm. So that's basically just a rock solid solution. And that's something which I think we should have better than with an IPv4 only experimental protocol that we typically bitch about. Obviously, as you said, only for the interdomain case, and it's unfair because obviously that was an impossible task, right?
Okay. So, I mean, I would say I'm not disagreeing with this draft. I'm disagreeing with some of your strategies for this draft because I think in some cases you're using this draft as a way to kill or club MSDP. So I guess I just wonder about the rationale.
Well, so let's go back, right? So I think the interesting rationale now is for the important constituency of enterprises using ASM. What is our preferred deployment model intradomain? I think that's basically the mesh group. Right.
So yeah, and we have that with 4610. You're just saying that 4610, we want 4610 with TCP. Is that?
Yeah.
Okay.
With a whole Yang model with all the features I know operationally to be important. Okay. But that's independent, right? Obviously.
All right. Cool. Got it. I was just hung up on your rationale.
Okay. Ronak?
Good.
Are we good? Do you want to ask anything about the draft?
Yeah. No. We would like to ask the PIM working group to adopt this document.
Okay. Go ahead.
I'm technically a co-author. So
okay.
Show your hands if you think that the working group should adopt this document. I see one hand. Two hands. Two hands. Okay, we'll make it official. Who feels that we should not adopt this document? Okay, so there's no hands. We'll take it to the list and we'll go from there. Thank you. Yes?
I think there are some folks who still want an intra-domain ASM, and I think in many cases they're misguided, that just about all applications can be done with SSM as well. And so the one thing I would be worried about is, do we want to continue pouring resources into ASM and providing more and more solutions to keep ASM alive, even in the intra-domain case, or do we want to help these people move along to the next thing?
Let's discuss that more. Great point.
No, I think-
We have 20 minutes left, Torlis.
Yeah,
We gotta move on. Sorry. Thank you.
Hello, everyone. I'm Ronak from Cisco, and I'll be presenting this draft for PIM null register packing. So as we know that PIM uses null register mechanism to refresh the multicast states at the RP from the first hop router. For one particular SG, we send one null register today. If the number of states, multicast states increases, if the number of multicast SGs increases, we'll have that many number of PIM null register that will be sent periodically from FHR to the RP. This could potentially cause drops, COP drops at the RP if in a large scale scenario. And eventually it can lead to expiries of the SG because the COP will drop the register that are being received at the RP. This problem has arisen from a customer issue that we have got, and we propose a possible solution in the draft. So the draft mainly proposes a method to actually pack all the null registers, to pack all the SGs in a single null register. Essentially, it could happen that in a network, you can have another RP which actually does not understand this message. So we also propose a compatibility checking mechanism by which RP actually can act and say that, okay, I do understand this message, so I'm ready for the packed null register message. Only when they both support packed null register messaging, this message will be sent from the first hop router. So essentially the advantage is actually to the overall null register packets in the network will reduce drastically. We'll better be able to utilize the control plane in case of scale especially. Also, it is relatively very easy to implement. It does not require any special or special writing of the code. We already walk all the routes for the PIM, for clubbing all the PIM joins prunes in one single message. All we have to do is actually pack the null register and send it to the RP. This draft was actually presented in IETF 101. Although we didn't receive any comments, I would like to know if there are any comments or if there are any feedback on it. I would love to know that. Thank you. I actually thought I had two people giving me comments, but one of them walked out and the other one went there.
Do you want anything from the working group?
Yeah, I mean, if I would like to have this draft adopted and have discussion on that.
Okay, very good. So we'll definitely have a discussion on it. But
Okay.
before we have a discussion on the list, in the room, who feels that this is a draft that we should adopt? I see three hands.
Four. I see four.
Four hands. Okay, I'll trust you on that. All right. Who feels that this is a draft we should not adopt? Okay, good for you. That's a promising. So we'll take that to list. And all right, next.
Pretty good
next
in the
presentation.
script.
That's pretty good.
Okay. Yeah.
The next one. So this is another new draft that we propose. So this is for the graceful insertion and removal for a PIM router. Graceful insertion and removal is very widely adopted by network administrator today in place of, in fact, sometimes ISSU or ISSD. Today, when a multicast router goes through maintenance mode, it leads to traffic disruption. And the goal for this draft is actually to make a GIR graceful so that the multicast router can be actually gracefully removed or inserted back into the network so that there is minimal traffic disruption. So this draft primarily discusses various scenarios, requirement, and a possible solution. We can have more discussion on it later, but the draft essentially has a possible solution for the same. As part of the current GIR procedure, the router who is undergoing GIR will send infinite matrix across all the routers in the network. This infinite matrix will lead to RPF change on all the routers. So the multicast flows needs to actually change the RPF to make sure that they point to the new path and remove the old path. But this RPF change has to be a little graceful in the sense that PIM should not change the RPF immediately to the new path as soon as it receives the unicast routing change. PIM should send the join message upstream and try to pull the traffic, but do not send a prune immediately. So the idea is mainly to do make before break here. Until the packets arrive on the new path, the downstream router will keep on forwarding, accepting the traffic and forwarding the traffic downstream towards the receivers. Once the traffic come on the new path, the RPF failed packet to the control plane will indicate that we have received a flow on the new path, upon which the RPF will be changed from old RPF to new RPF, and this change will be atomic, so it should lead to non-stop forwarding of the multicast traffic. The above method, this particular method of doing the graceful RPF change may not be advisable in the normal RPF change scenario, because it could happen that the old link could be down due to network failure or the link failure. So RPF may take more time, which could increase the convergence time. Therefore, we propose that this make before break model should be followed only within the GIR window. For this, the solution that we propose is that all the routers in the domain must know that there is some routers who is undergoing a GIR. And to achieve this, we actually take use of the PIM flooding messages, which is a PFM. We introduce a new TLV in the PFM message, and this is originated from the router who is undergoing GIR. This message is flooded across all the routers in the PIM domain, and it carries the start and the end time for the GIR period. The unicast matrix has to be adjusted in such a way that the unicast matrix should come in between the start and the end time. This can be done on the GIR router because there will be a particular procedure in which all the routing protocols will go down, and we can make sure that the unicast matrix change is timed in such a way that all the routers receive this infinite matrix in between the start and the end period. Once all the routers receive this infinite matrix, it will try to do the RPF change in a graceful manner, as we had discussed earlier. And this should hopefully lead to no disruption, minimal or no disruption in the multicast traffic flow. The same method can actually be followed for the graceful insertion of the router, and same method should follow for both of them. So this is a new draft. What I would like to know is your comments on it, any feedback, and if we could take this forward.
Jeffrey from Juniper. This make before break has been brought up before. In fact, some vendors actually have implemented. I forgot if we implemented it, but it can actually be used in a more general case, not just this graceful insertion removal, because if just a normal topology change, if the old path can still be used, even if it's not the best path anymore, obviously the implementation should be smart enough not to tear down immediately. You can still expect to receive the traffic on the old path until you receive the traffic on the new path. And then if the old path is completely broken, the interface went down, obviously your implementation should be smart enough to immediately to switch to the new path. So I don't think it needs to be specific to the graceful insertion removal, and I don't think you need the signaling to let everybody know.
Okay.
Yeah, I agree with Joe. I was about to say actually the same. So I agree with Jeffrey on the points. Okay.
So what you're saying is that basically we can, in general, we can do this make before break model and not specifically to GIR. In general, we can do it. The implementation should take care of making sure that if there is a link failure, it should be able to go to the new path immediately.
Right, and this is all local behavior. It does not need any signaling. It's local behavior.
It's local behavior. I believe it works for most of the gear that I've seen.
At least in the yeah.
We even killing ourselves to make it not traffic disrupting, even though applications at the end don't care because they buffer enough that we recover. And if applications do care, then you have a much better mechanisms that this will ever able to achieve, because you have a zero packet loss mechanisms then set up for multicast.
Okay, so from what I know of is that all the three OSs, at least in Cisco, we don't have make before break model on any of them today.
I would say that going back to this kind of reminds me of what we started with the DR thing. This is, and that's kind of what I was mentioning in the DR. I think this is a much better approach than those DR mechanisms, essentially, make before break. That would solve that problem as well. This is a generic case that solves a lot of, as opposed to that being a specific use case. I think this could kind of replace the DR problem we were discussing earlier.
Okay, thanks.
Yeah, you check also with ICE. I mean, as far as I remember, there were at least even published some optimization net space for MLDP at least, right? I don't remember the PIM side, but basically it's same issue, right?
We only have 5 minutes left and still one more presentation.
Actually, just two things that you may need to take into account. The one is again the duplicate traffic. The second thing is, because this PIM only works by hop, it's adjacent neighbors, not beyond that. And it's a reverse path forwarding. In certain scenarios and on how you build your topology, you may cause a loop between the routers for the signaling part.
Yeah, in the draft, actually, we have also mentioned the fact that since BFM message could carry a unicast prefix, all the routers can actually know who that unicast prefix is. So essentially, if you have a multicast state already with that prefix, you will only do this thing. Otherwise, you will not do it. As far as the message is concerned, that it goes hop by hop, I think the PFM message is flooded across the PIM domain. So I think we should be good there, right?
Yeah, we need to cut this
very quick.
Just one.
Very quick. So this is really just a very short-term MOFRR. You do MOFRR for a very short time, and then you send the prune on the old pass.
Okay. Yeah, we need to. Yeah, it's a good discussion. I wish we had more time, but we have to take it to the list.
Yeah, sure.
So
Thank
got
you.
one last presentation. Torles.
Okay, thanks.
Right. So don't move the slide. So this is a quiz. So who was in Mbundi? Yeah. So you're not allowed to answer. I want to build today, a network with the, most IETF well-recognized and standardized protocol for hosts to do multicast. Question: what protocol would that be? No? Okay, next slide. So there's pretty much only one of all these protocols that has the level of full IETF standard, not proposed standard, not draft standard, but full standard. And that is RFC 1112, which is specifying IGMP v1. So you don't want IPv6 and you don't want any of the newer protocols if you want to have a full standard. So that's kind of the problem statement, right? So the way that we have the standard levels of our protocols right now is mostly a sign of, procrastination on updating them. And when we brought up the whole discussion of retiring interdomain ASM, we basically got into, operators asking us what that means for them because they'd been happy with, let's say, IGMP v2 forever. They're running it intradomain with BIDR PIM or PIM sparse mode. They're scared of IGMP v3 and all of that stuff, right? And many operators seem to think that, IGMP v3, that is only SSM. You can't do ASM with it, right? Or no, it breaks ASM, right? So I think there is some good education to be done, but I think we should also, and that's something like an informational model which we may want to put into Mbondi. But for this working group, I think it's primarily the question of what can we do to adjust the status of the documents that we have to the reality of what actually is really the most widely deployed and recommended protocols. And it's certainly not IGMP version 1. Next slide. Right, so the whole idea, of course, is this work should not touch ASM, right? So we have all the discussion of retiring it interdomain and what we can basically do with the other drafts to evolve the protocol so we get rid of MSDP, or, basically just have a good standard stuff to do the mesh group internally. But let's say this particular work item, let's just focus on how we adjust the status of the best protocols and kind of downgrade the older ones. Next slide. So here is basically the list. The standard stuff is what they currently have, right? So we've got RFC 1112, which is kind of the Bible, the Holy Grail, the initial multicast protocol still alive. And so that, I think, is the biggest issue because that is also the only document that we have that is really specifying the ASM service model. And it's only doing it for IPv4. There is no specification in the IETF for the ASM service model for IPv6. But this document is two things. It's the IPv4 ASM service model, and it is the specification of IGMP v1. So I think the best solution would be to really, do a ref of it, remove all the IGMP v2 one, add IPv6, right? Wherever it says something about the protocol, kind of v4, v6, and that's basically the standard for ASM. Then it's just saying the service model. You join a group. That's pretty much all it says. Obviously, a bunch of interesting details, but really not try to muck around with it. Just, get rid of IGMP v1 so we can continue that as a full internet standard, obviously also for IPv6, and be done with it. So then we've got IGMP v2, proposed standard. Well, okay. So obviously we want IGMP v3, but what is it? What's the historic process, right? What's our downgrade options?
Right. So that's something I want to ask our AD about. Is historic the typical thing you would do if you want to have a full standard? You don't want people to use it anymore. Could we deprecate it, and do we need to come up with maybe 3 being full standard before we do that? Or?
I'll routing AD. So we can do whatever you guys want to do. That's the short answer.
What would you recommend?
Whatever you guys want to do.
Okay.
I'm not going to recommend. So what I'm going to tell you is this: there's two options, right? The option is to go either obsolete. Now, usually obsolete means I have a replacement specification for
Yes.
whatever, right?
Yes.
Which is not this, right?
That sounds good.
The other one is just change the status to historic. Now, the nice thing about that is that we can do a change of status in place. That means we don't have to do a new RFC 1112 BIS or something
Okay.
to replace the old one. We can just put in a justification of why we're doing this, take it to IETF last call, and that's it. Assuming no one opposes to that, right, of course, then we can just reclassify any of that as historic.
Okay, so what's the difference between obsolete and historic? Most simple process. So basically, you can make something historic without having something better, and obsolete, you must have something better.
Pretty much.
Okay.
Right? So in other words, if you're saying, yes, so in other words, there was an effort, if you remember last year, for making IPv4 historic,
right?
Where IPv6 is another version of IP. It doesn't completely replace v4, right? And so the intention there was saying, well, we really don't want to use IPv4 anymore.
Okay.
Like you might say, we don't really want to use IGNP version 1 anymore. I mean, it's there. We don't really want to replace it. We don't want to update it. We don't want to change it. It's there. We're just going to declare it historic because we don't think people should use it or whatever the justification may be. The process can be very simple. It can be just a paragraph that someone writes, and that's it. Or if you guys think there are...
Sorry, where does the paragraph go?
So the process is there is something called the status change document, which theoretically I write, but that means that you write. Explaining the... that's one thing I can delegate. The one thing I can delegate. Explaining why we're doing this. So if it's as easy as saying, well, no one really uses IGNP version 1 anymore. That's it. That's one paragraph justification. I put in data tracker. It gets last call, and that's it. 4 weeks last call, and we then change that. If the justification is bigger, or if there are exceptions, like we wanted to call ASM historic, but only for these cases, or I don't know, something really weird like that, maybe now we need an actual draft that gets discussed and processed through the whole process and everything else, where it talks about here are the conditions where you really shouldn't use this, here are the ones where you might want to use it, here's blah, blah, whatever. So that process is a little bit more complex.
So if, for example, the most difficult part of the whole scheme, I think, is the 1112, full standard for IPv4 ASM. I think the ASM part, I would love to see kept full internet standard, but not implying, the IGNPv1. So ref the document, remove that part. How much IETF process is needed to give it the status?
The full process, right?
Right. But again, I mean, if the only, textual changes are IPv4, IPv6, and you see, it's just the IGNPv1 removed, then is that...
Yeah, but we still have to go through the full
sure,
process.
Fine.
Right?
In terms of, yeah, okay.
Correct. So
Might still
we
be
can't make half of that RFC historic, right?
Right, exactly. That's
We
why I
either
was saying
make the whole thing, or
yes.
we don't make anything, or, whatever.
Exactly. Right. So that's the main issue, right?
Can I just ask a process question again? If we make it historic, does it prevent us from doing any changes from now on? Like, is this a word only? In which case, like, who cares? Really, almost. Or we actually, this actually has some meaning. So let's say we make it historic, or we have to make it obsolete, and like. Once it's historic, can somebody bring, oh, no, it's not that historic. Now I want to add a bit here, an extension or something like this. How does this work?
That's a good question, and it probably requires more than the negative 5 minutes that we have. So I think that in theory, because it went through IETF last call, and everyone agreed, not just the working group, not just you and me, everyone agreed, it means that we're not doing that anymore, right? So in theory, yes, no one should come back and say, oh, I forgot this bit, or I want to really add something because my customer's still using that.
So,
You know,
but
in theory,
basically
you do
that,
that
that seems
outside.
to me like if I still want to have ASM as a full standard, right, because I think it's valuable intra-domain, at least BIDR, right, I don't see that I ever want that to go away, then I would make the new document, which is just the ASM stuff, and then would call the other one obsolete, right, because it's superseded, and in the superseding, there is basically no IGMPv1 anymore.
Right.
Right. So that's
So to finish the answer to Andrew, now if someone, and I've never seen this happen, but if someone actually did come in with a bit, right, or whatever, that they wanted to still work on something that is historic, well, first you guys would have to discuss that, and I'm sure people will get up and say, no, we can't do that because it's historic, and it might not get adopted. It might only get one hand up, not the threshold of two. What is the threshold? 2 hands. By the way, we need to do something about 2 hands, right? I have 2 hands. We can't just, what? 4, 1. Oh, yeah, correct. But we need to do something about that. I mean, we need more something in this working group.
Yeah, by the way, we have like 5 minutes over time.
Yeah, so just let me finish. So even if it, yeah, so in any case, yeah, theoretically, if it's historic, no one works on it because there's going to be a lot of people who are going to object. Right? If it's not the working group, it's going to be outside the working group because people are going to say, well, that's historic, it shouldn't happen. You know, revise the whole IETF process and all that stuff.
So that sounds to me like something I would love to get MSDP into, right? Whereas this one kind of is more the obsolete stuff replaced by newer documents.
Right. Right.
Shall I quickly, just so you see the list, next slide. So obviously IGMPv3, we want to get to full standard. Stig was explaining already in the dry run on MBOND that one of the things we may need to do is to revisit if there is really crappy stuff that never has been implemented or been used. So I think that seems to be the exclude list of sources that we don't want to get in ASM mode. That is in implementations, I know it, but nobody ever used it in applications. So it's an underutilized feature. We don't know how well it actually works because no application seems to have been doing that. And actually, the other ones, let's skip. I think it's clear, right? MLDV1 downgrade, MLDV2 is the upgrade. Next slide. So I think the interesting one is then this lightweight IGMPv3 and MLDV2. And so basically that really the only difference is it actually has removed the exclude list. So maybe if we do a ref of IGMPv3 and MLDV2 where we cut out the things that we haven't been using, which is the exclude list, then we kind of supersede both existing IGMPv3, MLDV2 to full standard, kind of similar how the latest revision of PIM was done, where also stuff was cut out. And that should also supersede then 5790, right? So that seems to be, to me, reasonably logical and simple, if that's a conclusion, right? Yep, and that's pretty much, yep. That was pretty much kind of just, on this side, a possible strategy.
I think it's great. I think we should try to do a very quick change on, because half of this list probably there will be zero controversy, at least half I would hope. What to historic, what not to historic, and do a quick change. And then I think for some of the things, the ASM status has to get fully resolved so we can clean the rest.
Well, I mean, the biggest issue, I would have to ask Steve, right? So in terms of, what he would say, he owns the Bible, right? So I'll do that. And then basically the other ones, right? I think it's obsolete for IGMP v2, MLDV1, and then trying to figure out, do we simply want to upgrade with the process that Alvaro said, IGMP v3, MLDV2 to full standard, or do we want to go the step of removing these bits and pieces that we know haven't well been used?
So just to be clear, real quick, the quick process only works for downgrades.
Okay.
It doesn't work for upgrades. So if you want to go to internet standard, you need to go revise the whole RFC, make sure there's no errata.
How did RFC 1112 ever get full internet standard?
I have no idea. That was before I was born. I don't know.
No, but we did a quick
We-
process. No, wait.
Thank you, guys. We're done, but you guys can keep going.
We did a quick
Yeah, so beer was different because it was a very recent publication. And at the time of publication, everyone agreed that you would change the status. So
now basically every upgrade is latest new RFC.
Yes, so among other things, you need to make sure that